There is a continent at the bottom of our world, a place of profound silence and brilliant white. It is a land almost entirely covered by ice, a vast wilderness that holds secrets about our planet's past and clues to its future. This is Antarctica. For most of human history, it was a place of myth, a theoretical southern landmass that haunted the imaginations of mapmakers and sailors. Even now, in our connected world, it remains the most remote, the most mysterious, and the least understood continent on Earth. Its sheer scale and hostility make it a place where nature, in its most raw and powerful form, still holds dominion over all else. The fascination with Antarctica lies in its extremes. It is the coldest, driest, and highest continent on average. Its landscapes are sculpted not by water but by wind and ice, creating scenery of an almost alien beauty. Giant glaciers carve their way to the sea. Icebergs the size of small countries break away and drift into the Southern Ocean, and towering mountain ranges lie buried beneath miles of frozen water. To venture here is to step into a world that operates on a different timescale, where geological forces are visible, and the rhythms of life are dictated by the harshest conditions imaginable. It is a place that challenges our perception of what is possible on our own planet. Why should this remote, frozen land matter to us, living so far away in our temperate world? The answer is that Antarctica is not as isolated as it seems. The health of its immense ice sheets is directly linked to sea levels across the globe. The frigid waters that surround it drive ocean currents that influence weather patterns thousands of miles away. It is a natural laboratory, pristine and largely untouched, where scientists can study our planet's climate, the atmosphere, and even the secrets of the cosmos. The story of Antarctica is, in many ways, the story of Earth itself. In this exploration, we will journey to this southern continent. We will uncover its stark geography and understand its unforgiving climate. We will meet the remarkable creatures that have adapted to survive in this icy realm. We will retrace the steps of the heroic explorers who first dared to venture into its unknown interior, and learn about the groundbreaking science being conducted there today. It is a journey to the end of the Earth, to understand a place of critical importance to us all, a continent whose protection is a testament to our ability to cooperate for the good of the planet and for generations yet to come. Antarctica is a continent of superlatives, defined by its immense scale and its geographic isolation. Situated almost entirely south of the Antarctic Circle, it is the fifth largest continent, larger than Europe or Australia. It is a landmass nearly twice the size of Australia, yet its true shape is hidden beneath an extraordinary blanket of ice. This colossal ice sheet covers approximately 98% of the continent, holding about 70% of the world's fresh water. If this ice were to melt, global sea levels would rise by a staggering 60 meters, a fact that underscores its profound importance to every coastal community on Earth. The continent is not one uniform block of land. It is geographically divided into two major regions by the imposing Transantarctic Mountains, one of the longest mountain ranges in the world. On one side lies West Antarctica, a series of frozen islands and peninsulas linked together by the vast West Antarctic ice sheet. On the other side is East Antarctica, which constitutes the larger part of the continent. It is a massive, stable landmass, a continental shield of ancient rock buried under the much thicker East Antarctic ice sheet. This eastern sheet is a true relic of a bygone age, having existed for many millions of years. Beneath all this ice lies a hidden world. There are vast mountain ranges, such as the Gamburtsev Mountains, which are comparable in size to the European Alps, but are buried completely under thousands of meters of ice. Scientists have also discovered more than 400 subglacial lakes, pockets of liquid water that have been isolated from the outside world for millennia. The largest of these, Lake Vostok, is one of the biggest lakes on the planet, a dark, cold and mysterious environment that may harbor unique forms of microbial life. These hidden features are frontiers of discovery, offering tantalizing glimpses into a world locked away from sight. The coastline of Antarctica is dynamic and ever-changing. Massive floating platforms of ice, known as ice shelves, extend from the land out over the ocean. The largest of these are the Ross Ice Shelf and the Filchner Ronne Ice Shelf, each covering an area larger than many countries. These shelves act as buttresses, slowing the flow of glaciers from the land into the sea. Periodically, enormous sections break off in a process called calving, creating the gigantic tabular icebergs that are a signature feature of the Southern Ocean. This geography of ice and rock makes Antarctica a formidable and truly unique feature of our planet. The climate of Antarctica is the most extreme on Earth, a realm of cold so intense it is difficult to comprehend. It is, without question, the coldest place on our planet. In 1983, the Russian Vostok station, located deep in the continent's interior, recorded the lowest natural temperature ever measured on the surface of the Earth, a bone-chilling -89.2 degrees Celsius. The coastal regions are comparatively milder, but even there, winter temperatures regularly plummet to between -10 and -30 degrees Celsius. This profound cold is a direct result of its polar location, its high average elevation, and the reflective nature of its vast ice sheet, which bounces sunlight back into space. Beyond the cold, Antarctica is also the world's driest continent. It is technically a desert, a polar desert, because it receives very little precipitation. The frigid air is too cold to hold much moisture, so annual snowfall in the interior is equivalent to less than 2 inches of rain. What little snow does fall does not melt. Instead, it accumulates over centuries and millennia, compressing under its own weight to form the dense glacial ice that makes up the ice sheet. The winds that sweep across this frozen desert are relentless and powerful, known as katabatic winds, where cold, dense air is pulled by gravity down the steep slopes of the ice sheet towards the coast. The seasons in Antarctica are defined by an extreme cycle of light and darkness, a consequence of the Earth's tilt as it orbits the sun. During the austral summer, the sun does not set for several months, bathing the continent in continuous daylight. This period of constant sun provides the energy that fuels the brief but explosive bloom of life in the surrounding ocean. Conversely, the austral winter plunges the continent into months of complete darkness. The sun disappears below the horizon and the land is locked in the deep freeze of the long polar night, an isolating and profoundly challenging time for the few scientists who remain. These climatic conditions make Antarctica an incredibly hostile environment for life. The combination of extreme cold, aridity, ferocious winds, and the dramatic cycle of light and dark creates challenges that few organisms can overcome. Survival here requires extraordinary adaptations. The climate is not just a feature of Antarctica, it is the very force that defines it, shaping its landscapes, dictating the terms of life, and preserving the ice that holds so many of the planet's secrets. Understanding this climate is crucial, for it is a powerful driver of the Earth's entire weather system. In such a harsh and unforgiving environment, one might expect to find a lifeless wasteland. Yet Antarctica and its surrounding ocean teem with a surprising abundance of life, all of it uniquely adapted to survive the extreme conditions. The true heart of this ecosystem is not on the land but in the nutrient-rich waters of the Southern Ocean. Here, tiny shrimp-like crustaceans called krill form massive swarms, sometimes so dense they can be seen from space. These krill are the cornerstone of the Antarctic food web, the primary food source for a vast array of larger animals, from fish and penguins to seals and the great whales. The most iconic residents of Antarctica are, of course, the penguins. Several species make their home here, but two are true Antarctic specialists: the emperor penguin and the Adelie penguin. The Adelie penguins arrive in the spring to nest on the few ice-free rocky shores, raising their chicks during the brief summer. The emperor penguin, however, is a true marvel of endurance. They are the only animal to breed during the brutal Antarctic winter. The males stand together in huddled masses on the sea ice, incubating a single egg on their feet through the darkness and hurricane-force winds, a testament to nature's power of adaptation. Seals are also masters of this dual world of ice and water. The Weddell seal can dive to great depths and hold its breath for over an hour, using its strong teeth to rasp breathing holes in the sea ice. The crab-eater seal, despite its name, feeds almost exclusively on krill, using specially adapted teeth to filter them from the water. The most formidable predator of the Antarctic pack ice is the leopard seal. With its serpentine body and powerful jaws, it is a highly effective hunter of penguins, fish, and even the pups of other seal species, a true apex predator of this frozen realm. The Antarctic summer also welcomes giants. Whales journey south to the Southern Ocean to feed on the immense bounty of krill. Humpback whales, fin whales, and the colossal blue whale, the largest animal that has ever lived, all gather in these waters. And soaring above it all are seabirds like the wandering albatross, which has the largest wingspan of any bird on Earth, allowing it to glide effortlessly over the vast, stormy ocean for thousands of miles. This collection of life, all interconnected and dependent on the health of the Southern Ocean, makes Antarctica a place of incredible, albeit fragile, biological richness. For centuries, Antarctica was a ghost on the map, a terra australis incognita or unknown southern land that geographers believed must exist to balance the land masses of the Northern Hemisphere. It was not until 1820 that the continent was first sighted, an honor credited to a Russian expedition led by Fabian Gottlieb von Bellingshausen and Mikhail Lazarev. For decades after, exploration was tentative, confined mostly to the treacherous, ice-choked waters and the very edge of the continent. Whalers and sealers were often the first to chart new coastlines, their motives commercial rather than scientific, but their voyages slowly filled in the blank spaces on the world map. The late 19th and early 20th centuries ushered in what is now known as the heroic age of Antarctic exploration. This was a period of intense international interest, driven by national pride, scientific curiosity, and the pursuit of geographic glory. Men from Britain, Norway, Australia and beyond mounted daring expeditions, pushing into the continent's unknown interior. These explorers faced unimaginable hardships: scurvy, frostbite, starvation, and the constant crushing psychological pressure of isolation in the world's most hostile environment. They used, pretty rudimentary equipment, relying on wooden ships, sledges pulled by dogs or ponies, and their own immense fortitude. One of the most legendary figures of this era is Sir Ernest Shackleton. His 1914 expedition aimed to be the first across the continent, but his ship, the Endurance, became trapped and was ultimately crushed by the pack ice of the Weddell Sea. What followed was one of the greatest survival stories of all time. Shackleton and his crew lived on the drifting ice for months before taking to small lifeboats. He then led a small party on an astonishing 800-mile open boat journey across the notoriously rough Southern Ocean to the island of South Georgia, followed by a trek across its unmapped mountainous interior to find help. Miraculously, he returned to rescue every single one of his men. These early expeditions, though often ending in tragedy, laid the groundwork for our modern understanding of the continent. They were the first to map the coastlines, discover the transantarctic mountains, and confirm that Antarctica was indeed a continent, not just a collection of islands or an ice cap. The scientific data they painstakingly collected on geology, meteorology, and magnetism provided the first crucial insights into the nature of this frozen world. The wooden huts these men built still stand today on the Antarctic coast, preserved by the dry, cold air, serving as silent monuments to their incredible courage and endurance. At the heart of the heroic age of Antarctic exploration lies one of its most compelling and tragic stories: the race to be the first to stand at the geographic South Pole. This dramatic contest pitted two very different men against each other. From Great Britain came Captain Robert Falcon Scott, a Royal Navy officer whose expedition was a large-scale scientific endeavour burdened with the dual goals of discovery and national prestige. From Norway came Roald Amundsen, a pragmatic and intensely focused polar veteran, whose sole objective was to reach the pole first. His expedition was, frankly, a masterclass in efficiency and polar strategy. Amundsen's approach was built on meticulous planning and the use of techniques honed by Inuit peoples in the Arctic. He relied on skis for rapid travel and the power of over 100 sled dogs to haul his supplies. He established a series of well-stocked supply depots far in advance, ensuring his team would have what they needed for their return journey. On October 19, 1911, Amundsen and a small expert team set out from their base at the Bay of Whales. They moved quickly and efficiently across the Ross ice shelf, pioneered a new route up the Axel Heiberg Glacier, and reached the polar plateau with relative ease. Scott's expedition, by contrast, was beset by challenges. He chose a mixed transport strategy using Siberian ponies, motorized sledges and dogs, alongside traditional man-hauling. The motorized sledges broke down early on. The ponies, ill-suited to the extreme cold and deep snow, did not last long. Scott and his final party of 5 men were left to pull their own heavy sledges for hundreds of miles across the vast, featureless plateau. They endured terrible weather and suffered from frostbite and exhaustion, their progress painstakingly slow. Their journey became a truly agonizing test of human endurance against the elements. On December 14, 1911, Roald Amundsen and his 4 companions arrived at the South Pole. They planted the Norwegian flag, left a tent and a letter for Scott, and began their safe return journey. Just over a month later, on January 17, 1912, Scott's exhausted party reached the same spot, only to find the flag already flying. The discovery was a devastating psychological blow. Their return journey became a desperate fight for survival. Weakened by hunger and extreme cold, they perished one by one, the last 3 men dying in their tent just 11 miles from their final supply depot. Their story, found in Scott's diaries, became a powerful and enduring tale of British heroism in the face of defeat. Following the heroic age, the focus of Antarctic activity shifted decisively from geographic exploration to scientific research. The International Geophysical Year of 1957 to 58 marked a turning point. It was a massive, coordinated international scientific effort, with 12 nations establishing over 50 research stations across the continent. This collaborative spirit heralded a new era for Antarctica, transforming it into a continent dedicated to peace and science. Today it serves as a unique natural laboratory, a pristine environment where scientists can study our planet and the universe in ways not possible anywhere else on Earth. One of the most significant discoveries made in Antarctica was the hole in the ozone layer. In 1985, scientists from the British Antarctic Survey noticed a dramatic thinning of the protective ozone layer in the stratosphere high above the continent each spring. This discovery provided concrete evidence that certain man-made chemicals, specifically chlorofluorocarbons or CFCs, were damaging this vital shield that protects life on Earth from harmful ultraviolet radiation. This finding was a stark warning to humanity and directly led to the Montreal Protocol, a landmark international agreement to phase out these destructive chemicals, a true success story of science informing global policy. The ice itself is a remarkable archive of Earth's past climate. By drilling deep into the Antarctic ice sheet, scientists can extract ice cores, which are like frozen time capsules. These cores contain layers of accumulated snow, one for each year, stretching back hundreds of thousands of years. Trapped within the ice are tiny bubbles of ancient air, which can be analyzed to determine the composition of the atmosphere in the distant past, including levels of greenhouse gases like carbon dioxide and methane. This research has been fundamental to our understanding of natural climate cycles and has provided undeniable evidence of the recent rapid increase in greenhouse gases caused by human activity. Antarctica is also a window to the cosmos. The cold, dry and stable atmosphere above the high polar plateau offers exceptionally clear views of the sky, making it one of the best places on Earth for astronomy. Telescopes located at the South Pole can observe the faint residual heat of the Big Bang, known as the cosmic microwave background. Furthermore, the pristine ice is used in vast experiments designed to detect neutrinos, those elusive subatomic particles from space. And because the continent is largely free of terrestrial life, it is an ideal place to find meteorites which stand out clearly against the white ice, providing us with invaluable samples from other parts of our solar system. Antarctica may seem remote and disconnected from our daily lives, but it plays a profoundly important role in regulating the Earth's climate system. The immense ice sheet acts like a giant mirror, reflecting a large proportion of the sun's energy back into space. This phenomenon, known as the albedo effect, helps to cool our planet. The sheer size and brightness of the Antarctic ice cap make it a critical component of the Earth's energy balance. Any significant change to this ice cover would have far-reaching consequences for the global climate, altering temperature patterns across the world in ways we are only beginning to fully understand. The continent is also the engine room for the world's ocean currents. As seawater freezes around Antarctica, it expels salt, making the surrounding water colder, saltier, and therefore denser. This dense water sinks to the ocean floor and flows northwards, initiating a global system of circulation often called the ocean conveyor belt. This process transports heat, salt and nutrients around the globe, influencing climate and weather patterns far away in places like Europe and North America. The health of this circulation is vital for maintaining regional climates and supporting marine ecosystems worldwide. The stability of the Antarctic ice sheets is one of the most critical issues facing our planet in an era of climate change. The continent holds enough frozen water to raise global sea levels by approximately 60 meters. While the massive East Antarctic ice sheet is considered relatively stable, the West Antarctic ice sheet is of greater concern. Much of its base rests on bedrock that is below sea level, making it potentially vulnerable to melting from below by warming ocean waters. Scientists are monitoring these glaciers closely, as even a partial collapse of this ice sheet could lead to a significant and irreversible rise in sea levels over the coming centuries. The Southern Ocean surrounding the continent is also a key player in the global carbon cycle. Cold waters are able to absorb large amounts of carbon dioxide from the atmosphere, and the biological activity, especially the growth of tiny phytoplankton, draws down even more. When these organisms die, they sink, taking their stored carbon with them to the deep ocean, effectively removing it from the atmosphere for long periods. This natural process helps to mitigate the effects of greenhouse gas emissions, but the ocean's capacity to absorb carbon dioxide is finite and is being altered by rising temperatures and increasing acidity, another critical area of scientific study. Given its strategic location and potential for resource exploitation, Antarctica could easily have become a source of international conflict. However, in a remarkable display of foresight and cooperation, the world chose a different path. The spirit of scientific collaboration fostered during the International Geophysical Year of 1957-58 paved the way for a unique political agreement. In 1959, the 12 nations that had been active on the continent during that year came together to sign the Antarctic Treaty. This landmark agreement, which came into force in 1961, set the continent aside as a place for peace and science. The core principles of the Antarctic Treaty are simple yet profound. It states that Antarctica shall be used for peaceful purposes, only explicitly banning all military activities, such as establishing military bases, carrying out maneuvers, or testing any type of weapon. It also guarantees the freedom of scientific investigation and promotes international cooperation in research, requiring that scientific observations and results be made freely available to all. Perhaps most importantly, it puts a hold on all territorial claims. While several nations had previously made claims to parts of the continent, the treaty does not recognize, dispute, or establish any claims effectively freezing them. Over the years, the Antarctic Treaty system has been expanded with additional agreements to provide further layers of protection for the continent's unique environment. The most significant of these is the Protocol on Environmental Protection to the Antarctic Treaty, also known as the Madrid Protocol, which was signed in 1991. This protocol designates Antarctica as a natural reserve devoted to peace and science. It establishes a comprehensive set of rules to protect the Antarctic environment, including procedures for waste management, the prevention of marine pollution, and the conservation of its unique flora and fauna. Crucially, the Madrid Protocol placed an indefinite ban on all mining and mineral resource activities in Antarctica. This provision is a powerful statement of the international community's commitment to preserving the continent's wilderness values over any potential economic gain. The treaty system is a shining example of successful international governance, a model for how nations can work together to manage a shared global common for the benefit of all humanity. Today, more than 50 nations have acceded to the treaty, all bound by its rules to protect this precious, pristine continent from human exploitation and conflict. Antarctica stands as a powerful symbol at the end of the Earth. It is a continent of breathtaking beauty and scientific wonder, a testament to the power of nature in its most elemental form. From the heroic struggles of its first explorers to the cutting-edge science being conducted there today, its story is one of human curiosity, endurance, and ultimately cooperation. We have learned that this remote frozen land is not isolated from the rest of the world, but is intricately connected to the global systems that make our planet habitable. Its health is inextricably linked to our own. The future of Antarctica is at a critical juncture. The greatest threat it faces today is not from direct human activity on the continent, which is strictly regulated, but from the global impacts of climate change. Warming air and ocean temperatures are beginning to affect its ice shelves, glaciers, and unique ecosystems. The choices we make thousands of miles away through our energy consumption and greenhouse gas emissions will ultimately determine the fate of the Antarctic ice sheets and, consequently, the level of the seas in our own homelands. The future of this continent is a mirror reflecting the future of our entire planet. Protecting Antarctica is a responsibility we all share. The Antarctic Treaty system is a magnificent achievement of diplomacy, a promise from one generation to the next that this last great wilderness will be preserved. Upholding this promise requires constant vigilance and a continued commitment to international cooperation. It means supporting the scientific research that is so essential for monitoring the continent's health and understanding its role in the Earth's systems. It means ensuring that the principles of peace and environmental protection that lie at the heart of the treaty remain strong for all time. In the end, Antarctica is more than just a continent of ice and snow. It is a part of our shared global inheritance, a place that inspires awe and humility. It reminds us of the profound beauty of the natural world and of our capacity as a global community to set aside differences for a common good. Preserving Antarctica is not just about protecting penguins and ice. It is about protecting a legacy of peace, a beacon of scientific discovery, and a critical component of the planetary systems that sustain us all. Its fate and ours are intertwined.